All right, so back to this here. All right, so this explains everything you need to know about electricity for the most part, for at least the next hour. All right, we're going to be working with volts, amps, and ohms. And a lot of people like to equate this to water, but I'm worried that maybe you don't understand water. I don't know. So, but I'll explain it in water. But an amp or an ampere is the actual flow of electricity. It is like water running through a pipe. It is literally electrons flowing around atoms through wires or a conductor. So the amp is the thing that is going to move. And the volt is the thing that pushes the amp. It is the pressure that it makes. And the ohm is the restriction. So that's a restriction. Well, you can see it's a restriction. So the ohm restricts, the volt pushes, and the amp flows. So you have to keep that in mind, especially the fact that the amp flows and the voltage is pressure. And I'm going to say, when I talk a lot about volts, I'm going to say a difference of potential. So in other words, if I had a bucket of water way up here and a hose coming down, but I had it capped off, and I put a pressure gauge way up here and said, well, what's the pressure of the water? It's not really anything. But if I take the pressure down here, there's going to be some pressure. It's a difference of potential. It's the difference between the outside air and the pressure in the hose, right? It's going to make it shoot out. Now, if I take that hose and make it the same height as the bucket, do I have any difference of potential? It's not really going to want to run much at all. So it's difference. I'll say difference of potential. It's the pressure. And we'll get into that. Let me see. That's my Simpson meter. All right, so we're going to be talking about the Simpson meter. And I have one here, but now you can see it up here. The Simpson meter is going to read the three things for you. What are those three things? Volts, amps, and ohms. All right. And it was funny. I just had a conversation with Rich, and Rich says, I like analog meters, which is an interesting statement because most people, the first question they ask is, why am I learning to use an analog meter? And my answer is going to be because, number one, if you can understand an analog meter, you understand analog gauges, and you're that much better of a mechanic. Would you want to be that mechanic who's like, ooh, it doesn't have a digital readout, I can't read that. Kelly, can you please come and read the really difficult scale for me with the scary needle? Yeah. Do you want to be that person?
No.
Okay, I don't either. So if I can read an analog, then I can read the digital. So plus, when you go to your mechanic examiner, I'm asking the people who have graduated here, who have passed their test, without any problem. I say, hey, by the way, when you went to your mechanic test, which meter did they have you read? And the answer is both. So you better be able to read both, okay? And understand both and be very proficient with them. So if you can, once you get proficient and understand the Simpson, you can understand anything analog. It's really easy. So this is a great tool for analog. All right, so we are going to talk about ohms first. And ohms is what? What did I say it is? Restriction, okay? And ohms, the symbol for ohms is this right here. Who knows what that symbol is? Well, I didn't draw it very nice. There we go. That's a much nicer symbol. What is the symbol for ohms? Omega, or it's the ohm. If you prefer, as my daughter says, Dad, that's just Lululemons.
It is.
And if you don't know what a Lululemon is,
Yeah.
you're saving money.
I just bought 2 new pairs like a couple days ago.
2 new pair of Lululemon. You spent over $200 then.
Yes, I did.
All right, so
Yes, I did. I didn't even
they're
know
workout
about
clothes. Well, actually, you can either wear them as workout clothes, or me, they're my eating pants. So that's the
That's your Thanksgiving one?
That's right. All right, so that's going to be measured in ohms. We're going to talk about this right now. So it's a restriction. And restrictions in, there we go. Restrictions in electricity often look like this. These are resistors. And one of your first projects is to figure out how to decode these resistors. But you can decode them and you can also measure them. So we're going to talk about how we would measure something like that. So looking at this right here, we have all kinds of different scales. I'm going to tell you this right now. Ohms is different than everything else. We do ohms, and it's different. So if we look right here, this is ohms up here. And the ohm scale is right here. It's on the very, very tip top. All right? It goes all the way top. This right here is a mirror. Guess why they put a mirror here? Now the mirror is there to help you see how cool you look when you are working on the. No, it's called parallax, right? So you want to prevent parallax. So if you hold your pencil out in front of you, or your pen out in front of you, and you close one eye, it's going to cover one thing, and then close the other eye, and then it covers something else, right? It's like it jumps back and forth. Well, what you want to avoid when you're reading an analog meter is parallax. So if I've got it right here like this, and I'm way over here, it's going to look like my pen is kind of over there on top of Dallas. But holding it in the same spot, now it's over here on Aaron. So it'll be on Aaron. Right? But it never moved. So that gives you the wrong reading. So what you have is a mirror behind your needle. So when you look at it and you see your needle and you see a reflection in the mirror, you're off to the side. And so you move until the reflection goes right behind the needle, and that means you are accurate. Dead ball's accurate. It's an industry term. What movie is that from? My Cousin Vinny. The Two Utes, thank you. All right. Sometimes I'll show that movie. It's funny. So you know what I'm talking about. It's an industry term. Anyway, so we have the mirror. Now down here on the scale, I think I got a close-up of the scale. Here's my close-up of the scale. Some of these are a little different, but they're pretty much all the same. We're going to be working right here with resistance because the symbol for resistance is the omega, but it is also R. R for restriction. R is ohms. Notice right now that this has R times 1, R times 100, and R times 10,000. It is the only scale that has a multiplier on it. Nothing else has a multiplier, so stop multiplying stuff. You guys are my best class ever. You get people who are multiplying their other stuff. I'm like, there's no multiplier. So we have a multiplier. Okay, so remember that multiplier. I'm going to go to a big screen here so we can see a little bit better. Okay, so this one doesn't have the mirror. See, this is an older one, but it still has a good scale. So here is ohms, right? Now, if I have it on the R times 1, we'll put that right here, R times 1. What I'm going to do is I want to measure the resistance of something, and I didn't bring anything in to measure resistance with. But that's okay, we'll get over it. You'll notice there are little holes all over the place where the wires go. This is the standard spot for the wires, the default position, and it's on there as common and plus. So for 90-some% of your work in here, you're just going to have them right here, right? So you don't worry about it. And I'll teach you where to put them if we're going to move on to that. We could read the book. All right, so I want to measure resistance. The very first thing I need to do is, anybody care to guess? Turn it on! Okay, so this one here, the on button is right here. And we have one line that is for what? AC volts, which is alternating current volts only. You have DC negative and DC plus. You're going to be working with DC, yeah?
I don't know how to save the grades. Also, we need the paper opened.
The what?
Paper.
Oh, just click on another thing on the left. Like go to a different screen and auto saves it.
Cool.
Okay, so I'm going to turn it on. I'm going to turn it on to DC plus. Okay, that's just on normal. DC plus is on normal. DC minus, what that is, it's literally like taking this out and swapping places. In case you got something hooked up backwards, rather than having to switch these on the project, you just go DC minus and it electrically switches it inside. So that's what that is. All right, so first thing is I'm going to turn it on. Okay, very next thing you have to do with ohms, and only ohms you have to do this. And the reason why is because in the ohm setting, there are a bunch of batteries in here. There's a couple D cells, 9 volt, and they separate them out in 3 different ways in here. And because those batteries, of course, tend to sort of wear out, we have to always calibrate it all the time, every time we switch settings. So if I've got it on the R times 1, I have to calibrate it. And the way I calibrate it is I'm going to connect these 2 wires together. And when I connected them, this scale, I'll undo it and I'll try to do it again. This scale, huh?
You should measure out to 0.
Well, see, it's all the way over one way and now it comes up, and it should go to 0. 0 ohms means there is no resistance here, because there's no resistance, because I'm going to measure my resistance, so there should be no resistance here. But does this say 0? Can you guys see that? It does not say 0, because the batteries have wore out a little bit. So what it's doing is it's putting a little tiny current through here, back, and this is measuring how much current returned. So, well, the current's all returned. How much voltage drop, actually, is the word I should use. What is the voltage drop? Okay, so over here's a 0 switch, so I have to 0 it until I look in the mirror, and it says 0. Okay? That's how you calibrate
How
it.
did you do it?
This little knob right here says 0. See, it should be way off. Now back. I can't see it because you're looking at it. So way off, way off. See? The needle's moving. And now back. So I'm going to put it to 0. And you think, great, you calibrated it. But guess what? Did it just move off?
Nope.
No. Well, it usually does. So every time you switch, you have to recalibrate. Okay? Actually, it moved way past 0 on the other side. You can't see it. So now it's way past 0, so I go back the other way. Then I come down to this one. It went way this way. Now I go back the other way. So it is off every time. Now I go back to 1. And it's all the way off again. See? Okay.
When you recalibrate it, do you leave it in the 0 position?
You have to recalibrate it to 0 every time.
No, but after that,
I 0 it out, and then I can disconnect my leads, and I'm ready to start measuring.
no, but do you leave that knob at the 0 knob?
Don't touch that knob. Once you set it to 0, don't touch it again. Until you either switch settings. Even if I went to measure volts and go back, I'd recheck it. Okay. Yes?
So is it possible to make it go too far past 0?
Yep. Real far. So yeah, you can get it so that that line is somewhere. It should be right here at 0. You can get it way over here. And then when you go to measure something, it should be 2. It's going to be about here at 1. All right. Okay. So always got to turn it on. You have to calibrate it. Turn on. Turn on. 0 out. 0 out. That's how I'll say that. 0 it out. And never measure ohms with battery attached. Which is to say, never measure a circuit that has power to it. Why? Okay, what is inside of here? And the batteries are sending a little bit of current out and measuring the loss of voltage coming back. So if I add a whole bunch of voltage in there, guess what it does to it? Yeah, it's not happy. You're going to get a really bad answer. Yes?
What's that last word?
Attached. So power off. 0 it out. Turn it on. 0 it out. Never measure with power on the system. Got it? You have to disconnect your battery. All right, so if we look at, I'm going to erase this right here. Erase. Erase everything. Erase all. There we go. All right, so we have an R times 1. My selection is R times 1. R times 1. And, well, let's go to bigger scale. R times 1. Here we go. And if I had the needle was showing up right here, how many ohms do I have?
5.
That's equals 5 ohms. How did it equal 5? Well, this is 0, 1, 2, 3, 4, and it says 5 right there, 5. What about this right here? Down here, between here and here. What is that all about?
That's DC.
That's something else. This right down here, that's where we're headed to. This is DC volts and amps, volts and amps. We'll get to that. All right, what if it is right here?
12.
Okay, always make sure you stop and look at it. 10, 15. I try by ones. 11, 12, 13, 14, 15. Hey, that worked. So it is 10, 11, 12 right there. So that is 12. So that would be 12. What if it is, we'll go right here. Okay, that says 1K. That's 1,000. Now you're going to have to get used to using, let me see, abbreviations like that. So I have my screen here. All right, don't have a slide for that, so we're just going to do it this way. And this, there's a lot of them, but in this class, there are several that you must learn right off the bat. So, I think, what do I want you to learn? Milli, we'll do milli. Micro, okay, we'll do K. We'll start this way. K, which is kilo, which equals times 1,000. So anytime you see that, it's going to be times 1,000. It is also a number times 10 to the third in scientific notation. All right, the other one will be milli. Milli. I'm sorry, I should do it the same way. Milli. So it's M, little m. That's a big K, little m, which is milli, which equals times 10 to the negative third. So it is times, what would that be? 0.001. Point times 0.001. Okay, over here, this is scientific notation. What I'm writing, times 10 to the third, times 10 to the negative third. So a little bit ago, I had something that, what was the answer? 1 kilo? Okay, so I'm going to do it down here. So 1K equals 1 times 10 to the third. This right here is scientific notation. And it tells me how many zeros to add. Really, it's all it's doing. So it's 1 times 1, 2, 3 zeros. Okay? And it's not too difficult. Then, let's see, milli, kilo, milli. Which other ones do I think you should do? We'll do micro. Oops, I got to do the symbol. Symbol for micro is, it's called mu, which is like a cursive U. So that's micro, which is 10 to the negative 6. So 1, 2, 3, 4, 5, 6.
So is that microfarads?
Yeah, like microfarads. Make sure I did it right. 1, 2, 3. Yeah, I did it right. Okay, which is times 10 to the negative 6. All right, so if I said something like, I have 5 milliamps, there's the little m, which is right here. That is like saying 5 times 0.001 or 5 times 10 to the negative third. So let's just look at it right here. So 10 to the negative third. How many zeros do I add? Well, I got to move the decimal place. I shouldn't say zeros necessarily. It's moving the decimal place. How many spots do you move the decimal place? So because it's negative, that's 5 right there. I got to go backwards. So I can just add a whole bunch of zeros and go, well, how many do I go backwards? 1, 2, 3. So that equals 0.005 amps. So 5 milliamps is the same as 0.005 amps. What if I had 65 milliamps? How many amps is that? 0.065 amps equals 0.065 amps. And what if I had 10 milliamps? Micro.
0.00001.
Well, if you don't know, you can just put a lot of zeros and then put your 10 and start counting. So here we go. 1, 2, 3, 4, 5, 6. There we go. So it's that many. 1, 2, 3, 4 zeros because I moved it 6 places over. So it's 0.00001 amps. Very tiny amount. Okay. Where am I here? Back to here. Okay. So we had it right here on 1K. 1K is equal to how many ohms? 1,000 ohms. We should put the little ohm symbol there so we always know it's 1,000 ohms. If I ask you on a test something and the answer, what is it right there, and you put 1,000, you got it wrong because it's not 1,000, it's 1,000 Ohms. Okay. So that's really easy. Okay, we're on R times 1. All you do is just read the scale. Whatever the scale says is what you got. Now, I want you to note that we should, under most circumstances, have the needle in about the 2/3 area. It's more accurate in this area. All right, and you can see even going here. From here to here is 1. That's just 1 ohm. Well, from here to here is how many ohms? That's like 500 ohms spread right there. So that's not very accurate over here. And then I got this little spot right there. I can barely put my dot in. That's 1,000 right there. That's 1,000 ohms right there. 1K ohms. That space right there. And then this number right here, what's that number? There. Infinity. Just like the car. It means forever. So right now, if I have these things sitting like right this, what is it sitting on? Do I have no resistance or do I have infinite resistance? Right now it's infinite. How many resistances do I have right now? Resistances do I have? Okay, 0. Yes, how many resistances do I have? No wonder you guys get through this. Things like resistances. All right, so the next scale we had was R times 100. So if I set it on R times 100 and the needle is right here, how many ohms do I have?
800.
All right, so there's a lot of lines in here. So we can try by 1, 5, 6, 7, 8, 9, 10. Was that right? No, we'll try by halves. 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10. So 8. So I have 800 ohms. So I just count what it is, multiply it by 100. Hey, you can either just add 2 zeros, or I will never, ever make fun of anybody if they actually got their calculator out and said 8 times 100 is 800. I will never make fun of you. All right, there's no shame in that. I don't care, especially understanding that you have an instructor standing over you, breathing on your neck. You have bad breath, but usually Kelly will tell me, Kevin, your breath is bad. That's why I like her. Sometimes she just gags, and then I get the hint. All right, what if it is right here?
That'd be 500. No, 50.
500, 50,
No,
I hear 75, 75, 75 going. Well, I'm hearing 50. How much is this right here?
1.
That's not 1, it's 100. But we can go with 1 for right now and just add some zeros. So if that's 1, this is 2, 4, 6, 8, 1. 2, so it's 0.6 as a normal scale, but I have to multiply it times 100, right? So we can do 20, 40, 60, 80, 100. So it is 60 ohms. Are we following this? Okay, so you got to stop and you got to count. Right here, everyone on the R1 scale counts as 0.2. On the 100 scale, it's 20. Over here, everyone is like 0.5. So it changes all over the place. So you always have to make sure you knew. This is ohms. We're talking strictly ohms. You got to make sure you pay attention to what's going on. All right. Where's my? There it is. Couldn't see it. Zeus in here. Okay. And the last one is R time. Sorry. Try and use a color you can see really well. R times, I believe it's 10,000. All right. R times 10,000. So it's the same thing. If once you figured out the formula, if it's right here, how much is it? 20,000 ohms. All right. If it's right here, how much is it? Well, it's 10 plus 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. 1, 2, 3. So 100,000. All right. How about right here? $240. I'm hearing 240. Okay, so it's 20 1, 2, 3, 4. Is it each one count as 1? No. Okay, try it again. 20, 22, 24, 26, 28, 30. Okay, so that's 24 times 10,000. So 1, 2, 3, 4. 4 zeros. 1, 2, 3, 4 zeros. So 24,000. 24. Up 0, comma 0, 0, 0. Now, let me erase this right here. See if I can draw this in nicely. What if it is right here? In between those two. And we're talking. I'm asking you, actually I'm going to do it a little bit different. It's not quite in the middle. It's, well, let's leave it there. Good enough. So what is that right there?
Be like 13 and a half, 13.5.
Well, it just went away. Okay, so 13 and a half. Now, I'm okay if you and I are talking and it's right there. And I say, well, how much is that? And you look at it and go, well, okay, so that's 10, 11, 12, 13. You say it's 13 times 10,000. You go 13 times 10, 1, 2, 3 equals, okay, so that's 130. You're like, Kevin, that's 130. That here, so it's halfway between 130 and 140. If you said that to me when we're talking, I'm going to say, oh, that's fine. You understand it. I especially happens when it's just before. That's really where I was kind of going. So if it's just before 140 and you said it's just before 140, I'm happy with that answer. Okay? But if it's before 140 and I say, how much is that? And you go, it's 140. And you say, well, I'm sorry, you're wrong. You go, well, okay, so it's a little before. And I say, well, why didn't you just say that a minute ago? Right? So we always want to be as accurate as we can. But if you're telling me that you're inaccurate and you're like at a certain spot, then I know you get it. And that's all I'm really after. I want to know that you get it. And so, again, so if you look at it, it's a little before, and it's just a little before, and you give me some number, I'm good, you're good, right? Okay. I don't know if you're good. I'm good. All right, you want a break?
Yeah.
Yeah? You guys okay for a few more minutes? All right.